Assalamu alaikum. We know when light travels from one medium to another medium, it deviates. This deviation of light is referred as refraction. In this video, we'll get the equation for refraction at a single spherical surface. For that, I consider two media of refractive index N1 and N2 separated by a spherical surface. Let me show you how it appears. So suppose this is a spherical surface, a single spherical surface. If this is made up of a media or medium whose refractive index is nothing but N2. And here, this side, we have a medium whose refractive index is N1. Okay. Now, I take one point here at the center. I call it as P. Here P stands for pole. Pole of this spherical surface which has separated two media of different refractive index. Okay. Now, a line which pass through the pole is referred as principal axis. This is the principal axis and here P is the pole. Okay. Now, I take one point here. I represent letter C. This is the center of curvature. Now, what is this? Here C is the center of curvature of this spherical surface. Suppose if I continue this, it will form a sphere of which this is a center. So we call this one as the center of curvature of this spherical surface. Okay. Let me make it a little big. This line. This line is called as principal axis. Principal axis. Okay. It is passing through pole at a center of curvature. Now here I take one point represent letter O. Here this is a point object. From this point object I draw or I take a ray of light. This ray of light incident at this point on this spherical surface. Okay. Now before going ahead, here the line that goes through or the line that which passes through the center of curvature and meets at this spherical surface, which has separated two media of refractive index N1 and N2 is referred as normal. Okay, here I draw a line. This line is called as a normal. This normal. With respect to this normal, we measure the angle of incidence. All measurement is done with respect to this normal line. Understand? Right? Okay. Here, this incident ray incident at this point. Here, the angle between incident ray and a normal is taken as I. Clear? Now once this enter a medium of different refractive index, here I can say N2 is greater than N1. It means this medium is a denser medium and this one is a rarer medium. This is a rarer medium and this is a denser medium. We know very well, whenever light travels from a rarer medium to denser medium, it deviates from its path, and here the deviation is towards the normal. Okay, so here the deviation is towards the normal. Fine, and it incident this point. I name this point as I. Now at this particular point, it forms the image. The image of the object is formed at point I. Okay. Now this angle is taken as angle of refraction. This is taken as angle of refraction. The angle between a deviated ray and a normal is referred as angle of refraction, represented by letter R. Okay. Now I drop one perpendicular from the point where the light has incident on this spherical surface. This perpendicular line meets the principal axis at a point very close to the pole. Okay, draw a mark here. Yeah. Now here I have 3 points O, P and C. I take this point as D. This point is taken as D. This point is taken as E. This point, oh I'm sorry, already names into this. It is here, and this is N. Oh, Z. Already I given name to this. There is nothing but N. I have written this one here somewhere. Now I'll go ahead. Here I have got one, two, and 3 right angled triangle. Okay, fine. Now here I will apply Snell's law to this situation. Snell's law. What does Snell's law says? Snell's law. Snell's law says that the ratio of sine of incidence to the sine of angle of refraction, sine of angle of incidence divided by sine of angle of refraction is equal to the ratio of refractive index of the second medium to the first medium into divided by n1. This is called as Snell's law. Now I will cross multiply this to get Snell's law in multiplication form. Okay, how to get that? I take n1 this side. So I will multiply and I'll get n1 multiplied with the sine of angle of incidence I. Then sine r is taken this side. So n2 multiplied with the sine of angle of refraction. That is r. Okay. Now I box this. I'm going to take this one as equation number 1. Here equation number 1 represents Snell's law in multiplication form. Okay. The next see, if angle of incidence and angle of refraction both are very small, in such case, if I and R are very small, then Sin of I is taken as I, and sin of R is taken as R. Okay, this I am going to substitute here in this equation. See what I'll get if I do so. I'll get N1 multiplied with the I. So in the place of sin of I write I. The similar way, N2 is multiplied with the R, because in the place of sin of R I take a small r. Okay, this is equation number 2. Now how do we get this? What is the reason behind it? Let me explain this with the help of a simple example. Here, whenever you remember, in case of sin of some angle or tan of some angle, if the angle is very small, then sin of that angle or tan of that particular angle can be taken as the value of that particular angle. So something like this. See, suppose I have a sin of 0. What is sin of 0? Sin of 0 is nothing but 0. This clearly shows that when the angle is very small, then the sin of that small angle is taken as that angle itself. Okay, fine. This way, if theta is very small, then we take sin of theta as a theta. Got it? This is how we obtained the value of I and R. Got it? Now I name this angle NOP as alpha, and the angle NCP is taken as beta. In similar way, angle NIC is taken as gamma. Okay, here angle NOP is nothing but alpha. The angle NCP is taken as a beta, and angle NIC is taken as gamma. This symbol is alpha, this symbol is beta, and this symbol is named as gamma. Okay, fine. The next, let's see what I do. The first, I'll take this right angle triangle. Right angled triangle. NOP, triangle NOP. Let's see what do we get. Tan of alpha is taken as opposite side divided by adjacent side. Opposite is divided by adjacent side. Okay, this is what we get. What is the opposite here in this case? Here, the side which is just opposite to the angle is referred as opposite side. That is nothing but PN. So PN is the opposite side. Opposite is the PN. PN. And the adjacent side. What is this? This is the adjacent side is OP. And that is OP. Okay, then I'll go for the next right angle triangle, that is NCP. Triangle NCP. What do you get? Tan of alpha is equal to opposite side divided by adjacent side. What is the opposite side here? In this case, because of NCP, the opposite side is NP. divided by the value of adjacent side. This is the adjacent side. This is the what? PC. Okay. Here in the first case it was taken as the PN. In a similar way here also I will write it as PN. It will be same. Okay. PN. Fine. The next I take the third right angle triangle in the diagram. This is something what? NIC. In a right angle triangle NIC. NIC. Here tan of gamma. Here I have done a small mistake. Here the angle is beta, not alpha. So it is replaced with the beta. This beta. Fine. So here tan of gamma is equal to opposite side divided by adjacent side. What is the opposite side here in this case? The opposite side is PN again. This is the opposite side for this right angle triangle. And the adjacent side is IP. The side is IP. Now here, once again, if these angles are very small, say if alpha, beta and a gamma are very small, then tan of alpha is written as alpha, tan of beta is written as beta, and tan of gamma is written as gamma. This is what it means. Fine. Understand? Now, I'll go ahead. I'm going to substitute these three values in the equation. So, in the place of tan of alpha, I will take just alpha. So, these equation provides us the tan of alpha becomes alpha. So, alpha is equal to Pn upon OP. The next beta is equal to Pn upon PC. Then at the end gamma value is the what? Pn upon IP. Here we have the values of alpha, beta and gamma. This I am going to use the later stage. Okay. The next we'll see what I do. Now I'll take a triangle ONC. Triangle ONC. See what I do? Here, if you look at this carefully, it has got two angles, alpha and beta. If you add these two angles, then you get I. Okay, according to geometrical rules, because of this triangle. Here I have alpha, here it is a beta, and here the angle. What is this angle? This angle is I. So if you add these two, you will get I. So I write I is equal to alpha plus beta. Alpha plus beta. This is taken as equation number 3. Okay. The next I take this triangle NIC. Triangle NIC. You see what I get? Here I have got two angles, R and gamma. So if you add R with gamma, you get the angle beta. Here this provides beta. Here when these two are added, we get a beta. This is taken as equation number 4. We have got two equations now. Now, okay, instead of naming this as 4, before that I'm going to make certain changes to this. It is modified as. Here I keep R and a gamma is taken that side. So I'll get the value of R to be equal to beta minus gamma. This is another equation we obtained and is equal to equation number 4. This is how equation number 3 and 4 provides us angle of incidence and angle of refraction. Understand? Now I'm going to use equation number 3 and 4 in equation number 2. Okay? Substituting 3 and 4 in 2. Into. Clear? See, if I do so, here n1 is taken as such, then I is alpha plus beta is equal to n2 multiplied with the R value. What is that? Beta minus gamma. Okay. Now I just expand this. On expansion, what do you get? If I expand this, I get n1 alpha plus n1 beta is equal to n2 beta minus n2 gamma. Now I take this term here to the right hand side. Then this term is taken here to the left hand side. By doing so, what happened? n1 I get n1 alpha here minus n2 gamma will become plus n2 gamma when it is taken to the other side, plus n2 gamma, fine, is equal to n2 beta minus n1 beta, fine. Now I'm going to simplify this. See what I do. I keep n1 alpha as such plus n2 gamma is going to be equal to, here beta is common in both, so it is taken out. Beta multiplied with n2 minus n1. Fine. This is equation number 5. Equation number 5. Okay. So next, I know the value of alpha, beta and gamma. This I am going to substitute here in equation number 5. Substituting alpha, beta and gamma values in equation number 5. Let's see what we get by doing so. Here n1 is kept as such. In the place of alpha, I write its value, that is Pn upon OP. Now plus n2 multiplied with Pn upon Pc is the value of a beta, and is equal to, here we have beta. Now it's multiplied with, okay, what is the value of beta? Here beta is nothing but, okay, I have done a small mistake here. I should mention the value of gamma, which is nothing but Pn upon Ip. Pn upon Ip. Okay. Pn upon Ip. And here I should mention the value of beta. What is the value of beta? Beta value is nothing but Pn upon Pc. Pn upon Pc. Pn upon Pc multiplied with n2 minus n1. This is what we obtain. And here, if you look at this carefully, you may find that it has got similar terms. Pn is represented here. This 3 get cancelled. Okay, and now what we obtain is nothing but this. N1 divided by OP equals to N2, I'm sorry, not equal to, is plus N2 divided by IP is equal to N2 minus N1 upon PC. This is what I obtain. I take this as equation number 6. It is taken as equation number 6. Okay. Now I am going to substitute the value of OP, IP and PC in this equation to get the final expression. From the diagram, the value of OP is nothing but U. What is this? It is the distance between the object and the pole, which is taken as U, and here the distance between the image and the pole is nothing but V. So this gives the value of IP. And similarly, the distance between center of curvature and the pole is nothing but radius of curvature. Radius of curvature. Alright. So from the diagram, we get the value of OP. OP falls on the left hand side. So by following sign convention, OP is found to be equal to minus U. Okay, and IP value from the diagram, IP is nothing but V plus V, then CP is equal to capital R. Here R is the radius of curvature. Now I am going to substitute the value of OP, IP and CP in equation number 6. Substituting the values of OP, IP and CP in equation 6. So what I'll get if I do so, let's see what we get. We get this N1 upon, in the place of OP I write minus U, plus N2 divided by IP. What is the value of IP? IP is V, small v. Then it is equal to N2 minus N1 upon CP or PC. I'm sorry, that is taken as a CP, is not CP, it is a what? It is a PC according to this equation. So the value of PC is nothing but R. It is taken as R. So this is what we obtain. Now I am going to rearrange this. After rearranging, okay, N1 upon U minus U calculated as minus N1 divided by U. So I rearrange it. First I will take the positive term N2 divided by V minus N1 divided by U is equal to N2 minus N1 upon R. This is what I get at the end. I am going to box this. This final equation that I have obtained is named as equation number 7. This is called as equation number 7, and it is nothing but equation for refraction at a single spherical surface. Clear? Okay. Now, before conclusion, I am going to make certain changes to this final equation. Suppose the tensor medium is taken as a medium whose refractive index is n, and the rarer medium is taken as air. Suppose I take this as air, then if a rarer medium is air, then it's here N1 is taken as N, here N1 is taken as 1, because 1 is the refractive index of a rarer medium, refractive index of air, I'm sorry. Okay, so then N2 can be chosen as N. Now by substituting these values here in the equation number 7, what do I get? I get this. In the place of N2 I take N divided by V, and in the place of N1 I take 1 upon U, and I do the same thing here as well, N minus 1 upon R. Now this is what I get at the end. Okay, this is equation number, this is equation number 8. If a spherical surface of a refractive index N is placed in air, then the relation between V, U and R can be given by equation number 8. Now here this equation for refraction at a single spherical surface actually provides us the relation between object distance, image distance, radius of curvature of the given spherical surface, and refractive indices of two media, that is N1 and N2. This is what the relation it provides us. Okay. Now before I conclude, let me make it a little thicker. Let me make this diagram more prominent. Why? Here this is the refracted ray, and this is the incident ray. Okay, and here this is the spherical surface, now which divides the denser medium from a rarer medium. Okay, so I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put your questions in the comment section. Thanks for watching.